So, good morning everyone. Today, I'm excited to introduce you to a fascinating realm of artificial intelligence or sentiment analysis. Sentiment analysis is often referred to as opinion mining, and it's the field of natural language processing and machine learning that focuses on identifying and categorizing opinions expressed in text to determine the writer's attitude towards a particular topic, product, or service. So what a sentiment analysis does is quite remarkable. It sifts through text to identify and categorize the opinions within, aiming to understand the writer's attitude towards a specific topic, product, or service. So it's like having the pulse of public's mood and perspective in your hands. Okay, so next. So understanding NLP. So let's talk about social media. We know it's a big, but the sheer volume of user-generated content like tweets, reviews, and comments is astronomical. For business policymakers and researchers, this is an untapped reservoir of insights. By applying sentiment analysis to social media data, we can decode the complexities of public sentiment. This gives us a direct line into consumer behavior, unveils political trends, informs market research, and so much more. So it essentially translates the digital chatter into actionable intelligence. And so for understanding NLP, so now to understand sentiment analysis, we must first grasp the basics of natural language processing, or the NLP. Well, it's a branch of AI that's all about the interaction between computers and humans. So NLP is what allows machine to read, interpret, and make sense of human language. So like imagine the power of being able to understand the subtle size, the nuances, and the emotions behind the words we use. So that's the goal of NLP, and it's the cornerstone upon which sentiment analysis is built. So, and now we move forward to our next slides.
So, good day everyone. My name is James and I will talk about the key techniques in NLP for sentiment analysis. So this is the process by which we determine the emotional tone behind a series of words. This can be incredibly valuable for understanding consumer behavior, social media trends, and more. So first, we have tokenization. It's like breaking eggs to make an omelette. Here, we break down text into individual words or phrases to analyze them. So next is the stop words removal. We deal with stop words removal. So this is where we remove the filter words like and, the, or is. These words are common and don't typically add significant value to sentiment analysis. Then we have stemming and lemmatization. So if tokenization is breaking eggs and steaming shaves of the edges, and limitation gets us to the core, reducing words to their base or dictionary form, which helps in standardizing words for analysis. So part of speech tagging is our fourth technique. It's like understanding the whole role each player has in soccer game. We identify whether a word is a noun, verb, adjective, or so on. Next is name entity recognition, or the NER. Think of it as highlighting the VIPs in a text, identifying key pieces of information like names, places, and organizations. Finally, we have the sentiment scores. This is where we start assigning values to words based on their positive, negative, and neutral connotations. So let's move on to how we bring all these techniques together in the sentiment analysis processes. So once we've understood the key techniques, we move on the actual processes. It starts with data collection. So imagine casting a net to gather all relevant tweets, comments, and posts from the sea of social media. After we have our data, we move to pre-processing. Here, we clean or catch, removing anything that isn't helpful, like web addresses, user mentions, hashtags, and more. Next is feature extraction, where we decide which parts of the data will be the star performers in our analysis, which features will help us predict sentiment most effectively. With our features selected, we then begin with model training. This is where we teach our machine learning algorithms such as naive Bayes, SVM, or deep learning models to recognize patterns in the data that correlate with the sentiments. After the training, it's vital to perform an evaluation. Think of this as a dress rehearsal before the big play. We check the accuracy, precision, recall, and F1 score of our model to ensure it's ready for the spotlight. Finally, we have deployment. This is the grand opening night, integrating our model into applications for real-time sentiment analysis, ready to interpret the sentiments of text as they come. Next, we'll see a practical application of these steps through a case study. For our case study, we focus on the sentiment of tweets regarding a new product launch. Our methodology was simple and straightforward. We started with data collection using the Twitter API to gather tweets related to our product. During pre-processing, we cleaned the tweets for noise, removing URLs, mentions, hashtags, and special characters to get clear text for analysis. For the analysis, we utilized the pre-trained sentiment analysis model to classify the sentiment of the tweets. This model used the techniques we discussed earlier to understand the context and emotional tone of the tweets. Lastly, visualization was the key to presenting our findings. Through graphs and charts, we could easily display the distribution of sentiments, whether they were mostly positive, negative, or neutral. This helped us gauge the public reception of the product launch, allowing us to respond accordingly in our marketing strategies. With that, we conclude our presentation. Sentiment analysis is the powerful tool giving us insight into the vast landscape of public opinion. Next is the tools and libraries. Nakasum will discuss this.
So, ladies and gentlemen, today I'll be presenting about the tools and libraries essential for conducting sentiment analysis on social media. First is the Python. Python is a cornerstone programming language. Its extensive support and rich ecosystem of libraries makes it ideal for data science and natural language processing tasks. Next, for interacting with social media, particularly Twitter, we use Tweepy, a Python library that gives us access to Twitter API. This enables them to fetch tweets that can analyze for sentiment. When it comes to processing text, we have two powerful libraries that at our disposal, NLTK and Spacy. These libraries are equipped with functionalities for tokenization, tagging, parsing, and semantic reasoning, crucial for understanding the nuances in human language. And lastly, for building and deploying the machine learning models, we use scikit-learn for more traditional algorithms, and TensorFlow for deep learning approaches. These libraries allow us to create predictive models that can classify the sentiment of text such as positive, negative, or neutral. So now, let's talk about the results these tools helps us achieve. So we have a set of visualizations that represents our sentiment analysis findings. So at the top left, we have a sentiment ratio pie chart that breaks down the percentage of positive, negative, and neutral sentiments across our dataset. This gives us an immediate visual snapshots of the general sentiment trend. Below that, we see a sentiment ratio by channel bar chart. This comparison allows us to understand which platforms are harboring more positive or negative sentiments, and invaluable insights for targeted marketing strategies. And on the top right, we have a sentiment over time line chart, where we can track how sentiment fluctuates, identify patterns, and even correlate them with specific events or campaigns. All of this leads us not to just raw numbers, but actionable insights such as identifying peak sentiment times or understanding the impact of social event on public opinion. Now, this challenges and ethical considerations, but the journey is not without its challenges and ethical considerations. One of the significant hurdles we face is in interpreting sarcasm and irony, language constructs that are quintessentially human and often elusive for algorithms. Contextual meaning also possess a challenge, where words can have different meanings based on the context they are used in. This requires advanced NLP techniques to ambiguate. Moreover, in our global village, multilingual content is the norm, necessitating models that can understand various languages and dialects. And paramount among our considerations is data privacy. We're committed to adhering to privacy laws, ensuring user consent, acknowledging the importance of ethical data handling. So in conclusion, sentiment analysis in social media is a powerful tool, but it requires a careful blend of sophisticated technology and ethical responsibility.
Ethical considerations. Firstly, bias. Algorithms may inherit biases from training data, so it's important to have as large as possible for the analysis. Secondly, transparency. Social media users should know that their data are used and analyzed on. And lastly, consent. Users should provide consent for the data analysis when it is relevant or appropriate. Future directions. It can be used in advancements in deep learning, as deep learning models, especially those based on transformers like BERT and GPT, shows promise in better understanding the nuances of language. It can be used in real-time analysis, as developing models that can provide instantaneous sentiment analysis for live events and real-time interactions. It can be used in cross-platform analysis, as analyzing sentiment across different social media platforms to get a holistic view of public opinion. So, in conclusion, sentiment analysis using NLP has become an invaluable tool in the landscape of social media. It helps extract meaningful patterns and sentiments from vast amount of textual data, enabling stakeholders to make informed decisions. Continuous advancement in NLP and machine learning are paving the way for more accurate and nuanced sentiment analysis. That's all. Thank you.